Welcome back to my channel, guys. So in this video we are going to be considering absolute value inequalities and what problem, that is what problems leading to absolute value inequalities. If you are new to this channel, please remember to click the subscription button below and like this channel. Okay, let's continue with the examples we have at hand. Example 1. Express the fact that x differs from 3 by less than 12 as an inequality involving an absolute value and solve for x. Okay, x differs from 3 means x minus 3 by less than 12. So the absolute value of x minus 3 is less than 12. So x differs from 3 by less than 12 means x can be greater, minus 3 can be greater than minus 12 and less than 12. So solving this absolute value, now solving this, we have x minus 3 greater than minus 12 and less than 12. Okay, so adding 3 all through, so add 3 all through, we have this minus 12 plus 3 less than x minus 3 plus 3 less than 12 plus 3. Minus 12 plus 3 will give us minus 9 less than minus 3 plus 3, that's x, and less than 12 plus 3, which is 15. Okay, so the interval of the inequality is x greater than minus 9 and less than 15. And let us check if what we have is true. So x differs from 3 by less than 12. Okay, so minus 9 minus 3 is minus 12 and by less than 12 again. So 15 minus 3, we have 12. So it's actually work, and this can be given on a number line as minus 9 close at 12, 15 rather, 15. Okay, and this is the x-axis. So that solves the problem, guys. Example 2. Express the fact that x differs from minus 4 by less than 1 as an inequality involving absolute value, that is x differ from minus 4, this x minus minus 4, okay, by less than 1, less than 1. Okay, alright guys, so this is what we have here. So this can be written as x plus 4 or less than 1 and can be translated into x greater than minus 1 and less than 1. And if we solve this by subtracting 4 all through, we have x plus 4 minus 4 less than 1 minus 4, and that will give us minus 5 less than x less than minus 3 as the answer. Express the fact that x differs from minus 3 by more than 2. So this is going to give us x differs from minus 3, that is x minus minus 3, by more than 2, that is greater than 2. It's an inequality involving an absolute value and solve for x. So this is what we have. It can be written as x plus 3 greater than 2, okay, and can be translated into x plus 3 greater than 2 or minus x plus 3 greater than 2, and this is x greater than 2 minus 3, which is x greater than minus 1, or x plus 3 less than minus 2, dividing both sides by minus and changing the sign, we have that. So x is less than minus 2 minus 3, which implies x is less than minus 5, and we have both inequality as this one. So the distance of this goes this way for minus 1, and for less than 5 it goes this way, and this is minus 5, and this is the x-axis. Okay, so express the fact that x differs from 2 by more than 3 as an inequality involving absolute value. So we have x differs from 2, x minus 2, by more than 3 greater than 3. It's an inequality and solve for x. Now solving for x, we have x minus 2 greater than 3 or minus x minus 2 greater than 3. So here we have x greater than uh, 3 plus 2, adding 2 all through, which is x greater than 5, or x minus 2 less than minus 3, dividing all through by minus and changing the sign. We have that. So x is less than minus 3 plus 2, which implies x is less than minus 1. So drawing a number line to represent this, we have x less than minus 1 here. This is minus 1. The arrow goes this way, x less than minus 1. And for x greater than 5, we have 5 in this region, and the arrow goes this way. And this is x greater than 5, guys, and this is the x-axis. And that solves the problem. Another example, normal human body temperature is 98.6 degrees Fahrenheit. If a temperature x that differs from normal by at least 1.5, a temperature s that differs from normal by at least 1.5, that is the least, is 1.5. So s is greater than or equals to 1.5, is considered unhealthy. Write the condition for an unhealthy temperature x as an inequality involving an absolute value. So if the temperature that differs from normal by at least, so we have x minus 98.6, which is the normal body temperature absolute value, at least, that is greater than or equal to 1.5. That is the least difference between x and 98.6 is 1.5, so it can be 1.5 and above. Okay, so this is how to represent it, and this is the absolute value inequality representing the problem. Okay, so and then we are asked to solve for s. So this can be interpreted now, guys, as x minus 98.6 greater than or equals to 1.5, or minus x minus 98.6 greater than 1.5. And solving for x, we have x is greater than or equal to 1.5 plus 98.6, or x minus 98.6 is less than or equal to minus 1.5. Okay, dividing both sides by minus and changing the sign, we have this. So solving this, we have x greater than or equal to 6 plus 5, we have 11, carry 1, 8 plus 1 is 9, plus 1 is 10, we have 0, carry 1, 1 plus 9 is 10, so we have 100.1, or x is less than or equal to minus 1.5 plus 98.6, and that will give us x is less than or equal to this. 6 minus 5 is 1, 8 minus 1 is also 8 minus 1 is 7, and 9 minus 0, we have 9 there. Okay, so solving the inequality, this is what we have, and we can represent our solution on the number line to give this. This is 97.1. Okay, x is less than 97.1 goes this way. The circle is shaded because 97.1 is included, and we have x is less than or equal to 97.1, and this is the x-axis. Or x is greater than or equals to 100.1, so this is 100.1 here. The arrow goes to the right because the inequality is included, and x is greater than 100.1 here, and this is the x-axis. So that solves the problem, and these are the two solutions to the question. So this is how to solve a word problem involving inequality, guys. See you in the next video, where we'll be discussing a sign diagram and quadratic inequality. Remember to hit the subscription button and hit the like button. See you. Bye.